Hello everyone, my name is William Vukovich, and along with Patrick Christensen and Thomas Yeung of Hydrocarbon Publishing Company, I am here to present Refinery Power Outages, Causes, Impacts, and Solutions. I'd like to begin by giving a brief overview of what we'll be covering in this presentation. We'll begin by looking into the major causes of refinery shutdowns, and then delving deeper into the electrical issues that lead to these shutdowns. Following that, we'll look into the impacts that refinery power outages can have on your business. And next, we'll look into the solutions to these refinery power outages. These solutions have been divided into two separate categories, one risk management and the other being crisis management. And then finally, we'll conclude the presentation by giving our own recommendations for both refineries and to product vendors. When looking into the causes of refinery shutdowns, we here at Hydrocarbon Publishing found that there were over 2,800 different events that occurred from the years 2009 through 2014 that led to unplanned shutdowns within U.S. refineries. Looking into the actual causes of these shutdowns, we attributed 40% to mechanical issues. These are issues such as leaking valves or leaking pipes. Next were unplanned repairs and maintenance at 29% of shutdowns. These are events where issues were suddenly detected within processing equipment that called for a shutdown in order to fix the certain issues that were detected. But these were issues that were not noticed beforehand. At 20% of all shutdowns, we attributed them to electrical issues, which will be the focus of this report. And then finally, at 11%, we attributed those to other or miscellaneous issues. When we further break down the electrical related causes to refinery shutdowns, we could break it into 5 separate categories. The 2 least common, accidents and fires, accounted for a combined 4% of all electrical related shutdowns. Accidents are strictly work related errors, while fires are fires that break out that only impact electrical equipment. 12% of all electrical related shutdowns could be attributed to weather, whether it's hurricanes, extreme wind, extreme cold. These extreme conditions can cause major issues in electrical systems. At 29% of all electrical related shutdowns, equipment failure was the main culprit. This is where specific electrical assets such as a transformer or a circuit breaker or wiring ultimately fails to serve its main function and causes an entire system to fail. And accounting for the majority of all electrical related shutdowns, supply losses was the main culprit. This is an event where the third-party supplier for the refinery has its own failure and is no longer able to supply power to the refinery itself. Now that we've looked into the causes to refinery power outages, we can now look at the impacts that a refinery can face when consistently dealing with these power issues. We've categorized into 5 different groups, first of which financial performance will be addressed first, followed by energy efficiency concerns, next will be plant safety and liability, followed by environmental concerns and penalties. As you can see in the slide, we have created a 5th category, negative publicity, which is the result of plant safety and liability and environmental concern issues. To begin our look into the power outage impacts a refinery can face, we'll look at the financial performance issues that can occur. During any outage, regardless of the cause, flaring is likely going to be a result. This is a necessary safety procedure where hydrocarbons are released into the atmosphere or burned into the atmosphere in order to prevent pressure buildup and ultimate catastrophic damage. While flaring often will not impact the final throughput for a refinery, it is still nonetheless an event where hydrocarbons that could have been converted into product have been released and are no longer of use. Next, when we look at extended shutdowns, we can see that can have very costly impacts for our refinery. Based on our own calculations, we can see that a Gulf Coast 80,000 barrel per day FCCU is going to lose around $68,000 per day when refinery margins are at $1 per barrel and an 85% utilization rate. Now, these figures will go up even more if the cash margins are higher for a given time. And during any sort of power outage that causes major equipment damage, repair costs are always going to be accounted for. Next, we can look at the energy efficiency concerns that a refinery can face. Energy accounts for 43% of all operating costs for U.S. refineries, and motors can account for the majority of that energy consumption. Now, motors will consume twice as much energy during startup, and for a refinery that is constantly facing shutdowns, that means consistently restarting equipment is going to be highly consumptive of energy. And furthermore, motors can face reliability issues when consistently starting up and shutting down due to the high amount of energy required in order to start up these units. Next, we can consider the environmental concerns refineries face when consistently dealing with power outages. As I mentioned in the previous slide, any event where a unit has to shut down, they are going to have to release chemicals through flaring. This is where whatever hydrocarbons or other chemicals that are currently within the unit are released and burned off into the atmosphere. Now, this release is going to place chemicals such as SOx, NOx, aromatics, VOCs into the atmosphere that can pose safety concerns for both the personnel within the facility and the neighboring communities. When these events are deemed toxic enough, or if they're consistent enough, it's going to lead to potential government intervention and, if deemed necessary, fines for the refinery. And any time where a unit is going to be flaring, it's going to need flare monitoring and recovery equipment, which is going to add on to costs. Additionally, on a lesser note, these flaring events are very visually unappealing to nearby residents, and if it happens consistently enough, that's going to be enough to cause a public outcry. And finally, with the recent emphasis on CO2 emissions control, we can see that, according to the US EPA, flaring accounts for 2.5% of all CO2 emissions from a refinery. While some flaring isn't necessarily due to unplanned power outages, as sometimes flaring can be done during maintenance, that figure is a little bit skewed, but still, nonetheless, flaring can be reduced, and thus CO2 emissions can be reduced by limiting the amount of flaring occurrences. Next, we can delve into the plant safety and liability issues currently facing refineries when it comes to electrical systems. The poor operation or maintenance of electrical equipment is going to present serious hazards for the refinery involved. Arc flashes, electric shocks, and fires are known to cause serious injuries to the workers who are impacted by these events. And these events are usually the result of serious safety violations that are going to lead to an investigation and potential fines from government affiliations such as OSHA in the United States. And any event that causes a workplace injury is likely to lead to a lawsuit, which is going to further negatively impact the financial performance of a refinery. These environmental and safety issues, when they catch the public eye, are going to create very negative publicity for the refineries involved in these events. Now that we've looked at the impacts facing refineries, we can now look at the refinery power outage mitigation strategies that can either help a refinery better prevent or better cope with power outages. We divide these strategies into two separate categories: risk management, which are measures that are taken before an outage occurs to either thoroughly prevent or better prepare a refinery for such an event, and crisis management, which are the measures taken following an outage in order to either reduce the impact or protect the assets and workers on site. To begin, we'll start looking at the risk management strategies that a refinery can take. The first one to bring up is prevention and protection. This is a technological measure that involves the compliance with national standards that are set by affiliations such as the IEEE, NEMA, and NFPA for electrical equipment. This involves the understanding of both the internal and external factors that impact equipment reliability. It involves a thorough analysis in the causes of equipment failures and the definition of the specifications required for electrical equipment in order to perform the needed operational conditions and withstand major faults that are possible within a particular system. Furthermore, the investment into protective equipment such as relays, circuit breakers, and grounding equipment that are capable of isolating and absorbing electrical faults is highly necessary. These must be capable of working in all the possible fault conditions, and they must be resistant to degradation over time in order to ensure reliability. That last point is relevant for any sort of equipment within an electrical system. Continuing with risk management, finding the best solutions to a particular issue is always better done when first identifying the major causes to said issue. In this case, the quantifications of particular problems within an industry are readily available through shutdown databases, such as Hydrocarbon Publishing's shutdown database. This allows a refinery to track both the internal factors impacting their own specific refinery, as well as the external factors that are impacting refineries as a whole or within a particular region. This allows refineries to track their own internal issues and identify, as we call it, the problem children that are causing the most issues on the most consistent basis. Next, emergency preparedness involves the assessment of risks based on their likelihood and their consequence. Several analysis methods are available, such as the risk analysis matrix, latest protection analysis, and the process safety analysis, that allows refineries to both identify the causes leading up to a particular issue, as well as identify the measures that can be taken in order to prevent those issues that lead up to the eventual event. Furthermore, the understanding of the emergency procedures that are undertaken in order to minimize loss and ensure safety are going to be very unit specific and involve thorough research into the proper practices in order to prevent extreme damage or extreme safety issues. And additionally, the use of emergency response plans and communication is highly necessary. This involves both internally, where you can communicate with the workers on site in order to practice either mitigation or evacuation procedures, and external in order to identify the surrounding community of a potential outage and potential major safety hazard. Next, we can address asset management, which is a highly effective measure towards preventing equipment failures that lead to power outages. Asset management involves getting the most out of a particular piece of equipment by maximizing the effective running time and minimizing downtime and unwanted shutdowns. As seen in the figure, we can divide an asset's life cycle into 5 different phases, beginning with design, and then purchase and transportation, installation, maintainment and operation, followed by eventual disposal. Maximizing an asset's lifetime mainly involves maximizing the maintain and operation phase, as that's the longest phase out of the 5 shown in that figure. And the best way to maximize that phase is an emphasis on maintenance strategies that extend running time. Studies suggest that electrical equipment that is not under a maintenance program is 3 times more likely to fail. This is based on a study carried out by the Hartford Steam Boiler. And we can assume that planned shutdowns are always better than unplanned ones or run-till-failure strategies, where essentially an asset continues to run without any maintainment until it shuts down. The 2 most modern methods of maintenance are preventive and predictive maintenance. Preventive involves routine, thorough measurements that assess an asset's health. These are carried out periodically, and based on the method used, the time period between each assessment might vary. Predictive maintenance, on the other hand, involves a constant monitoring of key performance indicators, or KPIs, for assets that allow for an early detection of impending failure. Regardless of which strategy is used, effective communication is necessary. This involves maintenance staff, plant operators, management, and other parties being fully aware of each other's actions in order to ensure actions are taking place at the right time in order to prevent anything major. We'll conclude risk management by reviewing the use of on-site power generation as a means of preventing refinery shutdowns. If you remember from the analysis of causes to refinery shutdowns, we saw that 55% of power outages were due to loss of power from a third-party supplier. So, therefore, we can assume that the most effective means of shutdown prevention when power outages from third-party suppliers are common will be on-site power generation. These losses from third-party suppliers can be particularly frustrating due to the fact that they are out of the refinery's control. Currently, cogeneration, or CHP, is the most common approach within refineries since it's been proven in the past. While they have high capital investment, they offer long-term economic benefits beyond reliability and into energy efficiency. However, if we look into the future, we may see the increased use of alternative energy used within refineries, and potentially microgrids, which incorporate multiple power sources such as solar, wind, CHP, as well as third-party power supply in order to power a refinery. Controls are used in microgrids in order to determine how much power can be drawn from a particular power source based on the time of day. For example, on a windy day, you may rely more on wind. However, on a day that's not as windy, you may rely on a third-party supplier or a CHP unit in order to provide all the operating assets within a refinery. Now, whether you use microgrids or cogeneration, it's important to note that these applications can bring additional benefits beyond reliability, both economic and environmental. Since we've addressed risk management strategies, we can now delve into crisis management strategies, which are the measures taken following a shutdown in order to reduce the severity of the impacts refineries face due to power outages. We'll begin by reviewing unit shutdown and restart. This involves shifting from preventive measures to mitigation measures in order to reduce overall downtime and financial loss. First and foremost, we must ensure the safety of all personnel on site during a power outage and prevent further damage to any equipment that is impacted by the event. One measure, known as load shedding, is done in order to keep essential equipment online. This is done by using system controls in order to no longer provide power to certain assets in order to keep the more essential equipment running during a reduced capacity event. A refinery must have a clear and concise shutdown and restart procedure, and it must be well defined and carried out properly once the event actually occurs. And furthermore, separate strategies will be needed based on a total shutdown or a mere reduction in capacity to a unit. And, as alluded to in risk management, this will be unit specific, and there must be a strategy carried out that is specific to the unit involved in your refinery. Next, we can look at backup power supply as a means of adding redundancy to an electrical system. The two most common are either backup generators or uninterruptible power supply, known as UPS. These should act as temporary solutions while the original power source is recovering from whatever event caused it to go down in the first place. And, like any operating asset within an electrical system, it must undergo effective asset management in order to ensure that it is operating as is intended to when it is called upon. Continuing with crisis management, we can look at a strategy that is known as shutdown post-mortem. Anytime an unwanted event occurs, it's important to understand the factors that led up to the unwanted event in order to better prevent the event from occurring again. In a refinery's case, the best method used is root cause failure analysis, or RCFA. This is used because of the fact that it incorporates the knowledge of many technical fields in order to better understand all the operating factors involved that led up to the unwanted event. Because of the use of many technical fields, data availability throughout the entire refinery is vital for the RCFA's effectiveness. This is due to the fact that shutdowns are often the outcome of multiple cascading factors that may involve multiple systems at once. Once these cascading factors are understood, we can discover the underlying causes of power failures and unwanted shutdowns, and therefore determine the measures taken in order to prevent each cascading factor from occurring a second time. To conclude crisis management, we can look at a strategy known as salvaging equipment. This is a lesser option, but it is still very effective economically for dealing with damaged equipment that cannot be repaired. This is due to the fact that you can ultimately sell off parts in order to save capital costs on replacement equipment. We can conclude our presentation by offering our own recommendation for both refiners and product vendors. First, it is important for refiners to understand the risks of power failures. The financial losses, environmental concerns, energy efficiency issues, safety concerns, and negative publicity of power outages must be fully realized in order to know how to prevent the loss and minimize the impacts of power outages. Next, you must understand the underlying causes of power outages, both within your refinery and within the industry as a whole, in order to determine the best course of action for your facility. Continuing with our recommendations, we can reiterate the importance of risk management and crisis management for both preventing power failures and reducing the impacts of power failures. Risk management involves finding the best solutions that eliminate or reduce the likelihood of power failures. These can be both technological or procedural solutions. In either case, contact with equipment and vendors is necessary in order to determine the ideal operational and maintenance strategies for a particular asset within an electrical system. And finally, refiners should consider on-site power generation in order to decrease their dependence on third-party energy suppliers. But when using on-site generation, it is once again important to practice asset management for the equipment used on the on-site generators. Next, crisis management involves the ways to properly respond to power failures. Ultimately, crisis management can minimize the financial loss, flaring, and overall downtime from a power outage. Furthermore, practicing these two strategies are going to bring on additional benefits that can simultaneously improve efficiency, cut operating costs, lower emissions, and reduce the carbon footprint of a refinery as a whole. This presentation was a very brief overview of what is covered in our recent multi-client strategic report entitled Refinery Power Outage Mitigations. It will delve even deeper into the technological and strategic solutions refineries can carry out in order to both prevent and reduce the impacts of unwanted power outages. For more information on this report, you can visit our website at hydrocarbonpublishing.com/power. Thank you very much for your time.